Hi, my name is Jonathan, and welcome to part one of our dynamic routing presentation for SD-WAN. So what we're going to do is compare the underlay versus overlay routing, and we're also going to compare, look at OSPF and BGP. Remember, the underlay is the physical connections between sites, and the overlay is the OMP protocol and the fabric that's running on top of that system. Okay? We're going to use overlay and underlay a lot, so you're going to need to understand the difference between those terms. I'm going to keep mentioning this definition over and over again because it needs to be hammered home. We need to make sure you understand those because those words are used to describe very complex concepts, and I want to make sure we understand them. All right. So we're going to talk about underlay versus overlay routing. So underlay is the connection between sites, and overlay is going to be the OMP. When you see the word overlay, I want you to translate that word into your head and go that in your head to OMP, because that's what we're actually talking about. Okay? And we're talking about the dynamic routing protocols and their best practices. So, as I've said before, and I'm going to say again, the underlay transport network is the physical infrastructure above which the overlay is built. Okay? So if I've got an MPLS connection from a vEdge device into a network, that's my underlay network. If that site connects me to other vEdge sites, I'm going to run an overlay network that's going to create the tunnels between those sites. Okay? Basically, we can connect over any type of transport network. Public internet, MPLS, Metro Ethernet, 4G, point-to-point networks. If it has an IP address on both sides and the IP is pingable, we can build a tunnel to it. Okay? We're going to have some network considerations we need to be concerned with. Okay? Overhead. Packet delivery is going to occur at the network layer, so no additional packet overhead is going to be necessary. Multipath forwarding. We have multiple paths. There's going to be some overhead and complexity, and it is a little less scalable than in the underlying networks. And deployment time. Deploying new services in underlay networks is time-consuming to set up. Remember, if I have to create a connection between site 1 and site 2, 3, and 4, that's going to take a lot of time. But if I have just site 1 connecting to an MPLS environment and into an internet connection, I can use the SD-WAN to create all of those connections dynamically for me. Okay? So the overlay network consideration that we need to take care of, basically there's a substantial amount of overhead here. Packets have to be encapsulated to form a virtual link between the source and destination. Hence, additional packet overhead is going to be required. Multi-tenancy. We do have the ability to support overlapping IP addresses between multiple tenants on the same network. And multipath forwarding. We do have support for multipath forwarding within the network, and we can deploy this stuff very rapidly. Remember, we don't have to manually configure any of this at all. We can configure each site to connect into the environment, and then we throw on top OMP and the overlay network on top to create all of these virtual links. All right. So just so you're aware, your connection to your MPLS provider isn't going to change. Right? You have a PE, the provider edge, and a CE, the customer edge routers. Those are still connected to each other into your MPLS environment. Okay? And how you're connected, usually BGP, all right, is not going to change. Okay? The type of routing you use is going to depend on that local service provider. A lot of them are BGP, some are just statics, where they'll give you a /30, and you'll have an IP address, and you'll just have that as your default gateway. Okay? But we can use BGP, OSPF, or any even just static routing. If it's the only way of egress, a static route is fine. Generally, when a local site connects to a layer 3 VPN MPLS cloud, the vEdge is going to act as that CE device. So if I have a greenfield location, I'm going to deploy my vEdge as the CE device, my customer edge device. Okay? We're going to talk about in a later slide deck about integrating the two for brownfield deployments where there's already a CE router and that router is providing services that the vEdge can't perform, and we want to retain it. Cisco doesn't advise using router protocols on the transport side. In 99.9% of the cases, you simply use a default route on the WAN edge toward that transport. However, if you have multiple connections, one's internet and one's MPLS without internet, we may want to have separate routing for each of them. Okay? So how does overlay routing work? Well, basically it's going to be controlled by the overlay management protocol, okay, which allows the building of those scalable, dynamic, on-demand and secure IPsec VPNs. Okay? We use a centralized controller for easy orchestration with full policy control that includes that granular access control and scalable secure data plane between all edge nodes. We allow all those edge nodes to communicate directly over any type of transport network. whether the public WAN, internet, Metro Ethernet, etc., and anything else. And we support BGP and OSPF unicast routing protocols. If you're going to ask, yes, eIGRP is not supported at this time. As I understand it, it is in progress, but I don't have any more information than that. And you can configure all of these protocols on the VH routers to provide the reachability that you need to connect to those sites. So the whole purpose of this is that we want to enable routing on the service side of the network. So remember, we have two sides of the network. We have the underlay and the overlay network, which is between the vEdges, vSmart, and all the other sites. These are where your MPLS, internet, etc. are, right? This is each site connecting. Then we have the services side. Okay? This is where we're providing service. These are the side we're providing services to. Okay? So if you think of the services side, I want you to think of that's the side that's using this SD-WAN solution. They're the user side of the network, if you will. Okay? And from that side, we can run BGP, OSPF, and statics, and connected routes as well to connect back to the devices, those server-side devices. Okay? To set up routing on those, you provision a VPN or multiple VPNs if segmentation is required. So what we can do is we can have a VPN 1, right? Remember, VPN 1 through 511 are going to be the service-side VPNs. All of this in here is VPN 0. And then this connection is VPN 512. This is getting cluttered. Let me erase some of this. So VPN 512 connects directly to vSmart. VPN 0 connects full mesh to the other sides inside. This is where our internet connection is where our MPLS connections are. VPN 1 through 511 are your service-side networks. Okay? And we can run OSPF, BGP, static, or have connected interfaces there. Okay? So within each VPN, so let's say we have VPN 1 because we're talking about a service-side VPN, right? We assign the interfaces that are on the inside of those devices, so these guys, into that VPN 1 through 511. We can segment those as needed, right? Or we can run routing protocols as needed also to make sure that we propagate routes the way we want to. Okay? So remember, this side of the network, the vSmart side of the network, has no access to what's going on back here. There's actually a strict line of demarcation through the router, through these vEdge devices, from this side of the network to the other. Okay? vSmart only cares about VPN 0 and VPN 512. It does no information on VPN 1 through 511 as far as what's happening back here. Okay? So we bring a route in, all right, and what we're going to do is redistribute it into OMP. And we'll talk about that in the next couple of slides. Okay? So we have three types of routes we're going to talk about. We have OMP routes, TLOC routes, that's transport locator routes, and network service routes, which we're going to talk about in the next couple of slides. All right? So if that looks confusing, we're going to explain it in detail, so don't freak out yet. Okay? So the very first one I want to talk about is OMP routes. These are the routes that are learned from the service side. Okay? So remember, we have on the service side, we have OSPF, BGP, and static and connected routes. What we're going to do is redistribute those into OMP. Okay? Basically, these are all the prefixes we learned from within that certain VPN at the local service side via those routing protocols or static. The most important attribute added to OMP routes, as they are advertised through OMP to vSmart, is as follows. The transport locator, right, and the site ID, which is going to indicate what other vEdge advertised them. That's where they came from, okay? So that system IP, the TLOC, by the way, is just another way of saying that it's is going to consist of that thruple we talked about before. So that it's going to be the system IP address of the device, what color identifying the link type, and the encapsulation type, whether it's IPsec or GRE. It's going to usually be IPsec. GRE's unusual. Origin is going to be the source of the route, whether it's BGP, OSPF, connected, or static, and whatever metric we associate with the original route. Originator is going to be the identifier of the originator of the route, which is the IP address from which the route was learned. So if we learned a route from this guy, that's going to be added as the origin system IP. Okay. The preference, degree of preference for an OMP route, the higher preference value is more preferred. For example, we may prefer MPLS routes from another area over here versus routes over the internet. We still want the internet routes because if the MPLS fails, we want that route already to be in the routing table for us to use as a backup. Okay? And what network service is associated with the OMP route? There might be IPS or an IDS or some kind of firewall inserted into the as a service insertion. And which site ID these routes came from. Okay, remember every single site. So if I have multiple V edges here, okay, all of these are going to be in the same site. And we'll talk about that in the coming slides as we start talking about redundancy and other preferences. And what VPN number was back here? What service side VPN they came from? Okay? To which that route's going to belong. Now, those OMP routes are going to get into vSmart and then distributed back to all the other V edges with all of this information in them. So when you do the route, you're going to see what transport locator, site ID, color, et cetera, and what the origin of that route is. Okay, so if you do a show route on a V edge, you'll actually see all this information. All right, the next type of routes we're talking about are going to be the TLOC routes. These are the transport locations. Okay, these are locations in the overlay network that connect to physical transport, i.e. the underlay network, MPLS, internet, et cetera. Basically, the point that which the WAN interface is going to connect to the router, the carrier. It's denoted by a three-tuple that consists of the system IP of the OMP speaker, color, and an encapsulation type. And OMP is going to advertise each TLOC separately. They advertise the following attributes. Okay, the TLOC private IP address, the private IP address of the interface associated with the TLOC public IP address, NAT translated address of the TLOC, just in case it's actually behind a NAT device. The carrier, an identifier of the carrier type, which generally used to indicate whether the transport is public or private. A color, identifying the link type. Remember the color, we have public and private colors. So if I have a public color, that means it's accessible via a public IP address. If I have a private color, it's accessible by a private IP, and we generally won't create control connections over it. Encapsulation type, of course, which mentioned before, which is going to either be IPsec or GRE. And the preference. Again, we're going to prefer MPLS, or if let's say we have a specific QoS-enabled circuit for, let's say, some low latency service that we use, like voice or video, we're going to want to prefer that voice and video traffic to use that low latency circuit versus the internet circuit. We still want to use the internet circuit if we lose it, but again, we want to prioritize that traffic over the site that is QoS enabled. And a site ID, again, we talked about that, and an optional tag, which is some path attribute that the OMP speaker can use to control the flow of routing information toward a TLOC. When we start looking at policies, this tag will start to make a little bit more sense, and when we start acting on that tag. Anyway, basically, when an OMP route is advertised along with its TLOC, you can distribute both or either with a community tag to be used to decide how to send traffic to or receive traffic from a group of TLOCs. And a weight, basically to use to discriminate among multiple entry points if an OMP route is reachable through 2 or more TLOCs. Okay? All right? And the last one is our network service routes. Okay? So these are the routes behind on this side of the V edge. Okay? Remember, when I say service, I mean the actual prefixes and services that we're providing at the site. Okay? So if you've got the 10.1.3.x 0.x 24 network back there, we want to make sure that that reachability is advertised out both of our transports, right? So that other V edges in the environment have that reachability back to you. Okay? Remember, the goal here is full connectivity. We want a full mesh network without creating a full mesh network. Okay? So the hub and local branch vEdge routers are going to use these service routes to advertise the services available in their networks to the vSmart controllers in their domain. They maintain service routes in their routing information base, and the vSmart controllers do not propagate these routes to the V edges. Each service route, SAFI, has the following attributes. Okay? A VPN ID identifies the VPN that the service belongs to. A service ID identifies the service being advertised by the service node. We have the following predefined services. Firewall matches the service ID 1, IDS, service for intrusion detection systems, for service ID 2. We have identity providers, and we also have some network services that can be identified out as well. We also have a label for the traffic that must traverse a service. vSmarts replaces the label in the OMP route with the service label in order to direct the traffic to that service. We also have an originator ID, basically the IP address of the service node that is advertising the service, and a transport locator, address of the vEdge that is hosting the service, and the path ID to identify that OMP path to get there. So we're going to advertise these routes to the vSmart controller through OMP, of course. Depending on the network topology, some routes might be advertised from multiple vEdge routers. Devices, you're going to use the following algorithm to choose the best route. First up, we're going to check to see if it's valid. If it's invalid, then there's no reason to put it in the routing table. If it's valid and has been learned from the same device, select the route with a lower administrative distance. The default administrative distance for OMP is 250. So if you remember, OSPF is 110, external BGP is 20, and IBGP is 170. So OMP is going to be learned after all of your service-side routes are learned. If the administrative distances are equal, select the OMP route with the higher OMP route preference value. And on vEdge routers, if the OMP route preference values are equal, select the OMP route with the higher TLOC preference value. If the TLOC preference values are equal, compare the origin type and select one in the following order. Select the first match: connected, static, eBGP, OSPF inter-area, external, IBGP, and unknown. Okay? So, now remember, Cisco does not recommend using routing protocols on the transport side for VPN 0. In 99.9% of cases, just use a default route pointing at your WAN provider. We're going to reserve OSPF BGP for the service side, the inside of the vEdge, the customer user side. So, basic configuration is pretty straightforward. We're going to go through the OSPF feature template. Remember, we build features, then collect features together on device templates. Don't worry, we're going to get there. All right, so basic service-side OSPF functionality using a configuration template. Remember, we're going to go into template, configuration, templates, and then instead of device, feature. We're going to select feature. Now, in that, you're going to select OSPF is going to be a button for it, and you're going to select that OSPF button. And then once you do that, you're going to select router ID. Okay? So by default, the system ID uses the router ID. Don't do that. The reason being is that because we're generally going to be talking about the inside of your network. So we're going to be using OSPF to other devices. And if you ever need to create a virtual link, that route IP address needs to be routable to OSPF inside the service side, the local LAN side. So what we're going to want to do is we're going to want to set this as a variable for the router ID that's something reachable inside that environment. Okay? We also can set our administrative distances if we want, or just leave them at the default of 110. Don't change your administrative distances unless you have a reason to do so. Generally, this is going to be site-specific. Okay? And basically, we can leave these others at the default. I would definitely change the router ID to be a variable and make that a real IP address for the inside. Remember, this is going to be site-specific to that site. It's going to be probably that IP address that's pointing at the OSPF neighbor device that you're going to connect to. Okay? Now, we have to choose the protocol from which to distribute routes into OSPF. In the example in the slide, we're going to choose OMP. I'm going to use this little white space down here to describe this. So we have our OMP cloud. Right, and these are different vEdge devices connected to each other. We're going to learn routes from each site via OMP. We're going to want the OMP to redistribute into the service-side routing protocol so that when we talk OSPF, we can get those routes reachable. So as the vEdge device that's connected to that side of the network, we'll learn all of its the transport devices, all the SD-WAN routes via OMP, bring them into OSPF, and then advertise them to our OSPF routers on the inside of the network. Basically, the whole goal here is that any routes learned from the overlay, the OMP network between them, will be redistributed to the service side, our local routing. Optionally, if you want to, you can apply a local route policy to influence that route redistribution. In this case, we're going to enter the name of a localized control policy to apply the routes before they're distributed into OSPF. Okay? You also might, another option is you could also have a rule on the other OSPF side for a route filter to only allow specific routes into that environment. Basically, let's say we only want to redistribute routes to the data center and not to necessarily every other site. Obviously, now with people needing any communication, that's not much of a there's not a lot of justification for it. But for other networks, you may want a site to only have access to its data center, for instance. Okay. Basically, and then once you've got OSPF, you scroll down. So you're going to be down at the top here. That's where we're configuring the IP address at the router ID. Then we're going to scroll down to area, and we're going to add a new area. So click here, click, and then enter the new area. So you're going to enter an area number. Remember, OSPF does require an area 0. However, if we have a separate OSPF area for this site, area 0 may be a hop away. So we may be in area 3 on one side and connecting area 0. But we have to connect to area 0 at one point. Okay? Basically, we're going to enter the area number, the area type, and the participating interfaces. And if we want to set up a type 3 summary link state advertisement set, we can click add range, which is right there. Okay? And then they're basically OSPF summary routes. So let's say you have a bunch of sub routes. You can actually add one supernet of it, and it'll suppress the sub routes that are members of it. Okay? Okay, and then when you hit add range, it'll bring it up here. You can enter your area range address, its cost, and you can also set it to no advertise. The whole thing is that we basically are setting up an OSPF route in an area boundary, so that only a single summary route is advertised as opposed to all those child routes to other areas in that area on that area border router. So what we're going to do is that we enter the summary address and mask in the format in the CIDR format. Remember, everything's going to be entered here in CIDR, so IP address / and then mask, and then we'll route cost. And so the no advertised, if you do click on this, the type 3 summary LSA, or click off to advertise them, and then click add when finished. Okay. Remember, click this at the end, and then you're going to have another one at the back there. And then if you scroll down to the advanced session, for example, we can optionally configure the default route originate. So if we want to originate the 00 route, we can do it here, and whether or not to do it always, or whether it's only available, whether it's still in the routing table. Okay. And then we can set a default metric. And what else can we do? And we can also set our metric type down here as well. I think that's off down that way somewhere. It's not showing on the screen. Okay, and then once you do this, when you push this to the router, you're actually going to see this is the CLI that's going to get configured. All right, and this is pretty straightforward. If you're used to configuring OSPF on a Cisco router, it's the same here. All right, so we're putting it into a VPN, so we know which interfaces to apply it to. Remember, this is service side, so it's not VPN 0 or 512. Instead of router OSPF 100, it'll be router then OSPF. So we're telling it that we want routes from OMP to be redistributed into OSPF. We're specifying our area 0 and what interfaces. So these two interfaces are going to be in area 0. We're exiting out. We're no shutting our interfaces. And then on OMP, we're advertising our OSPF routes to it. Okay? This way we basically have mutual redistribution, which is always a great idea. We can also set up passive interfaces. So if you don't want OSPF hellos being sent out an interface, we can do that here. We can also set up MD5 authentication and set up hello and dead timers, etc. Generally, OSPF, you don't want to change your timers unless you have a really, really good reason to do so. And then the default information originate, which we could do with a checkbox before. Okay? And then we can have area summary, area range commands as well. And you'll note here also that stubby and not so stubby are also supported if you need to. Oh. Sorry, one more thing I want to mention. OMP routes by default are not redistributed. No routing is redistributed anywhere on the system unless you specify it. BGP to OMP, OMP to connected. Actually, the only thing that's actually by default advertised into OMP are connected. Okay? And we can also verify this. If we go into vManage, we can click on the monitor tab. It looks like a little computer monitor. That's why it's monitor. Anyway, click network. And we can take a look at our OSPF neighbors and verify our routing over the routing table for each VPN. Okay. Basically, we would select the device, click select real time down here. Real time gives us a little box, and we can actually select our show commands from up there. Okay? And if you do an OSPF neighbors, it'll show you what their status is. And we want to see them, of course, in full, which means that they're up. Okay? And we can do a show IPOs, show OSPF database. We're only IP, so we would only be show OSPF database. Okay? So we don't support IPX anymore for some reason. All right? And of course, you can do all of this from the CLI. Remember, even if we're completely covered by vManage, you can still do all your show commands on the vEdge device. You just can't configure from a device once it's connected to vManage. Okay? And show OSPF neighbor and show OSPF database, of course, are going to look the same as a router. Okay? All right. So, as we've been talking about, you can build that SD-WAN overlay network over any transport provider. We've said that about 6 times now. I'm going to say it 3 or 4 more times. Remember, if I can ping it, we can build a tunnel across it. And just remember, we can run dynamic routing protocols to our service side. And the service side being, of course, that inside network that we're connecting to the SD-WAN environment. Thank you for watching, and stay tuned for section 2 of dynamic routing protocols.